Hello, my name is David On from the KGSEA Math Circle, and today I'm going to talk about the binary search algorithm. Before I start, all the code in today's lecture is going to be in the Python programming language. So before we talk about the algorithm, we're just going to be briefly review the conditionals and iterations. The conditional statement usually consists of three statements: if statement, elif statement, and else statement. The code in the if statement executes if the if statement is true. Elif statements are executed only when the if statements are false and their conditional statements are satisfied. The else statements will only run if the if statements and elif statements are resulted in false. If you look at the picture, the first if statement is going to be executed as false because the conditional statement that the x is less than 4, but 5 is not less than 4. Now we're going to look at the elif statement since the if statement is false. Now, when we're looking at the condition, y is greater than or equal to 10. Since y is 10, it meets the condition, which will lead to executing the code inside the elif statement. The else statement will not be executed since the elif statement was already satisfied. For the iterations, it's really simple. We're just repeating the same process over and over. There are two types, the while loops and the for loops. We use for loops when we know exactly how many times we are going to iterate, and while loops when we do not know how many times we're going to iterate. If you look at the picture, we can see that we use the for loop when we already have the range for the value y initialized, which shows how many times the loop will run. However, for the while loop, we can see that we do not know when the loop will end since a is not initialized, which shows that we do not know when the loop will end. 잠시만, 망쳤는데요? 잠시만요. 아,
괜찮아. 끊고 다시
네,
갈래?
네,
어,
잠시만요. 이 슬라이드부터 다시 시작할게요, 이거.
하고 싶은데 선생님 편집해 줄게.
네. 도중에 뽀록이 나가지고. 음, 그냥 아까 루프 시작할 때부터 다시 할게요, 이거.
아니야, 기왕이면
네.
페이지 한번 넘기면서 처음부터 해. 그게 나아.
아,
오케이.
여기, 다시 할게요. Before we talk about the algorithm, we're just going to briefly review the conditionals and iterations. The conditional statement usually consists of three statements: the if statement, elif statement, and the else statement. The code in the if statement executes if the if statement is true. Elif statements are executed only when the if statements are false and their conditional statements are satisfied. The else statements will only be run if all the if statements and the elif statements are resulted as false. If you look at the picture, the first if statement is going to be executed as false because the conditional statement is that x is less than 4, but 5 is not less than 4. Now we're going to look at the elif statement since the if statement is false. When we look at the condition, y is greater than or equal to 10. Since y is 10, it meets the condition, which will lead to executing the code inside the elif statement, and, and therefore the else statement will not be executed since the elif statement is already executed. For the iterations, it's really simple. We're just repeating the same process over and over. There are two types, the for loops and the while loops. We use for loops when we know exactly how many times we're going to iterate, and while loops when we do not know how many times we're going to iterate. If you look at the picture, we can see that we use the for loop when we already have the range for the value y initialized, which shows how many times the loop will run. However, for the while loop, we can see that we do not know when the loop will end since a is not initialized, which shows that we do not know the specific times the while loop will run. One important thing for the loops is that we always need an increment or decrement of the loop control value, in this case, a in a while loop, or either the loop will go on forever. Now let's dive into the binary search algorithm. What is a binary search algorithm? It is a method or an algorithm that finds the position of the solution value within a sorted array. It cuts out the positions of arrays that do not contain the answer each iteration. So let's say that we have an array that contains 1, 5, 11, 12, 20, 22, 25, and 38. Since the length of array is 9, as there are 9 values within, the index will be 0 to 8 in ascending order, as the computer counts from 0 rather than 1, like humans. The target number we are looking for is 25, which has the index 7 in the sorted array. If you look at the figure, we are going to know that we're going to compare our target value, which is 25, to 15 in the array. But why does it have to be 15? The reason is simple. We're going to add the index of maximum number and minimum number in the array and divide that by 2. That leads us to 0 plus 8 divided by 2, which is 4. We can note that the index value of 4 is 15. However, we know that 15 is less than our target value, 25. So 15 and the values that are smaller than 15 are never going to be the answer anyways. After, we can know that the index value lower than 4 will never be the answer, as indexes were assigned in ascending order, meaning index values lower than 4 have actual values lower than 15. So we can cross out the index 0, 1, 2, 3, 4 out of the list since they are not the answer. With this sequence finished, our first iteration is done. After we take those values out, we have to reassign them the array values. Since 15 is lower values and were taken out from the list, the smallest number remaining in the list becomes 20. Also, the maximum number becomes 38. We're going to assign then the index from 0 in ascending order once again. If you look in the diagram, you might be thinking, oh, why do I see the values that were taken out of the list? Now, do not get confused as I just put them in there for your better understanding. You'll notice that there are no index values assigned to them, so just assume that they do not exist in the real array. Back to content. Our next step is to get our comparing value again, as the former comparing value, 15, was removed from the original list. The smallest index is 0, and the greatest index is 3, and when we divide those two added indexes, we get a result of 1.5. However, the computer's division generally just cuts off the decimal point rather than raising to the next whole number, so the comparing index value is 1, cutting the 0.5 away. Index value 1 is 22 in the current list, so our current comparing value to our target is 22. We know that our target value of 22 is still lower than 15, so I can cross out that 22 and any numbers with the lower index, as the list is still in ascending order. With this sequence finished, our second iteration is done. Now our third iteration has started. We have to assign the index values in the array again to the remaining numbers. Since 25 is the smallest of the remaining list, it'll be given an index value of 0 and 38 will be given 1. And that'll be it. Then we are back to setting our comparing number. Our minimum index is 0 and maximum index is 1. So when we add those two values and divide that by 2, we get a result of 0.5. After that 0.5 is cut off as we're doing general computer division, which gives us a result value 0. Since the index value is 0, we can know that the actual value the index value refers is 25. Now our comparing value matches the target value, which is 25. Since the target value is found, the iteration ends. We can know that we found the target value during our third iteration. If we just checked all the values, the target value would have been found during the 8th iteration, as it goes through 1, 5, 11, 12, 15, 20, 22, and then it finally reaches 25. Here's a GIF that shows the binary search algorithm in a fast way. We can know that the binary search algorithm is much faster in finding the designated value. You can see the steps compared. Now, let's try to solve a coding problem using the binary search algorithm. This problem is called echo. The problem says, Lumberjack Marco needs to chop down M meters of wood. It is an easy job for him since he has a nifty new woodcutting machine that can take down forests like wildfire. However, Mirko is only allowed to cut a single row of trees. Mirko's machine works as follows. Mirko sets a height parameter h in meters, and the machine raises a giant saw blade to that height and cuts off all tree parts higher than h. Of course, trees not higher than h meters remain intact. Mirko then takes the parts that were cut off. For example, if the tree row remains with heights 20, 15, 10, and 17 meters, and Mirko raises his saw blade to 15 meters, the remaining tree heights after cutting will be 15, 15, 10, and 15 meters, respectively, while Mirko takes 5 meters off the first tree and 2 meters off the fourth tree, so he gets 7 meters of wood in total. Mirko is ecologically minded, so he doesn't want to cut off more wood than necessary. That's why he wants to set his saw blade as high as possible. Help Mirko find the maximum integer height of the saw blade that still allows him to cut off at least M meters of wood. So this means that we have to find a specific number that'll give exactly the needed amount of wood after we cut them. For example, if we need 7 meters of wood and are given 20, 15, 10, and 17, just like the problem said, the specific number of giving exactly the needed amount is 15, because 20 minus 15 is 5, and 17 minus 15 is 12. When we add that remaining 5 and 2, we get a result of 7 meters of wood. 15 and 10 will not give any woods as they are the same or smaller than the specific number we set, which was 15. Okay, the input is going to consist of 2 lines. The first line is going to be the number of trees with the limit of 1 inclusive and million inclusive, and Mirko's needed amount of wood with a limit of 1 inclusive and 2,000 million inclusive. The second line is going to be height of each tree. Still, the added value of all tree heights would have to be greater than the Mirko's needed amount of wood in the first line of input. The output is going to be a 1 number. The height value of the saw blade we need in order to get the exact amount of wood from cutting that value. Now let's think about it. First, we need to get the 2 lines of input. We will use the variable n for the input number of trees and variable m to show the needed amount of trees. We will also initialize an array called tlist to get the tree heights inputted in there. Then we will set the variable start as our smallest index 0 and set the variable end as the maximum value in the list using the max function. Now it gets a little bit complicated. We will use the for loop since we do not know how many iterations we would have to go through to reach the target value using the binary search algorithm. We will set a variable mid that adds the minimum and maximum value and divide that by 2. The value will be exact, including the decimals, so we use the double slash to divide, since you're dealing with actual numbers. So we will set the variable sum, because we're counting the current wood amount accumulated to 0. So each time the while loop runs, the sum will be reset to 0. By using a for loop, we will subtract each wood amount from the current mid value and accumulate that subtracted value to the variable sum. After we're done accumulating the wood, we will compare if our current sum is greater or less than m, targeted amount of wood. If sum is greater than m, 1 will be subtracted from the maximum value, and if sum is greater than m, 1 will be added to the minimum value and run the entire while loop again. This process will repeat until it finds the correct value. The reason we're using binary search algorithm is because the values we might have to go through might be big as millions or even billions, and it'll take a whole lot of time for the computer to run the entire values one by one in that case. So thanks for watching this lecture about the binary search algorithm, and I hope this lecture contributed to your learnings of algorithm and computer science. Thank you.